Hello, and today's purpose of the day is I can identify parts of the coordinate plane, plot points on a coordinate plane, and identify the domain and range of a relation. Let's take a look at the coordinate plane and some important aspects of it. I zoom in here and I look at this top arrow. This is pointing to the y-axis. So the straight up and down line here of the coordinate plane, that represents the y-axis. That's vertical. The horizontal line is called the x-axis, and here I can highlight that, and that's the horizontal axis, otherwise known as the x-axis. This very middle center point at 0, 0 is called the origin. And I'll represent that by writing 0, 0. So the ordered pair that would be right at the center of the coordinate plane is called the origin. Up here in the right-hand corner, this arrow, this entire area here is called quadrant 1. And we'll represent 1 with a Roman numeral 1. It's typically how we would write quadrant 1. Now if I go counterclockwise, if I go to the left, here this box up here, that is represented by quadrant 2. And again, Roman numeral 2. And so that means that any ordered pair that falls within that square would be in quadrant 2. And same thing with quadrant 1. Any point, I could put like a point here, like those ordered pairs are in quadrant 1, whereas like all these ordered pairs here would be in quadrant 2. And if we continue going counterclockwise, quadrant 3, there we go, quadrant 3 is in the bottom left-hand corner. And then lastly, quadrant 4. And again, Roman numeral 4. So we'd represent that by writing a V and then a 1 in front represents subtracting 1. So I'd be, for example, 5 minus 1, so that would represent 4. And those are some of the important aspects that we will talk about for the coordinate plane. Now let's practice graphing on the coordinate plane. I have a list of ordered pairs here on the left that I am going to go ahead and graph on the coordinate plane. So let's start with this first example here. A is at 3, 4, and we talked about the x and y axes on the last slide. And so how we graph this ordered pair is we are going to graph them by x, y, which means here 3, 4, we're going to move out along the x-axis first, 3 units, and that's a positive 3 units, so I'm going to go 3 units to the right, which would be, right here is 3, but then I'm going to go up 4, so up 1, 2, 3, 4, and I'm just showing you here with the lines how we would go about, those blue lines there, go about looking at our coordinate plane to actually make the point right there at 3, 4. And then I can go ahead and I can label that, and I can say that's point A. Now let's graph point B. Negative 2, 6. So I'm going to go along the x-axis. Negative 2 spots, so that's to the left 2 spots, and then up 6 units. So that'd be right there for letter B. Okay, let's look at C. Negative 2, negative 2. So I'm going to go to the left negative 2, and then down negative 2. That would be C. Letter D is over 5, down 3. Again, I'm going along the x-axis first and the y-axis second. Letter E is at 3, 0. So I'm just going to go to the right 3 units and then not up or down anything. So that's actually right along the x-axis. And that's letter E. Letter F, I'm going to go 0 to the left or to the right, and then down 3. So that will be along the y-axis, and that's letter F. And then lastly, G at 0, 0. Again, we talked about that in the last slide. That's right at the origin. That's right at the center of the coordinate plane. All right. Now let's take a look below here, and let's consider the coordinate system at the right with the certain ordered pairs, and then we'll find the coordinate pair of each point. So now we're just working backwards a little bit from what we just did with the above examples. So if we look here at letter A, I'm going to notice that it is over 5 units and then up 6. And again, I just drew with those lines so you could see how I'm visually looking at how to make that ordered pair. So that ordered pair here would be 5, 6. And we represent the ordered pairs with parentheses just as we saw them above. All right, letter B is back -2 spots. So back to the left, and then to the left represents a negative, so -2, and then up 2. So that ordered pair would be -2, 2. Letter C is over 3 units on the x-axis, and that's +3 because we're going to the right, and then it's not up or down anything, so it's just 3, 0. Letter D is to the left and right 0, but then it's just down 3 units, so 0, -3. Letter E here is to the left 3 units, so -3, and then down 5, so -5. Letter F is over 5 units, I can see on the x-axis, and then down 5 units, so 5, -5. And there actually is no letter G here on the coordinate plane, so I'm just going to go ahead and cross that out. Now let's move on to identifying the domain and range. The domain is the set of all x values, or we could call this the independent values, or independent variables. Range is the set of all y values, or otherwise known as the dependent variable. So let's practice identifying the domain and range of the following relationships. So the domain, again, goes with all the x values. So I'm going to look at this list of ordered pairs, and I can even, to start with, underline all the x values. And those are all represented by the domain. And we typically write the domain from least to greatest with the numbers. We use brackets around the outside of our domain, and we separate each number with a comma. We also do not write any repeats. So that means if we see 2 of the same number, we do not write the repeat. We do not write the number twice. We do not repeat the number. So I'm going to start here with the domain. I'm going to make my brackets, and this also goes the same for the range. And I'm going to list them in order from least to greatest. And I see a 1, a 2, a 3, ooh, and then another 1. So I'm not actually going to write that. So I'm just put a little X above that so I don't write that. And then a 4. So I'm going to, and that's actually already in the least to greatest order. So 1, 2, 3, 4. And then I'll represent that the domain is completed by also writing a bracket on the end of that set. And the better you'll get at drawing brackets is just by practice. So practice making those as best as you can. All right, for the range, I see a 2, 5, 1, 6, and 8. So there are no repeats, but I do need to put those in order from least to greatest. So I'm going to make my brackets, and I'm going to go ahead and put the 1 first, 2, 5, 6, and 8. And sometimes, as you noticed, I like to, if it's a long list of numbers I need to write, I like to put a check mark above it or, next to it, so representing I already wrote that number. So that just helps keep everything organized. So again, written least to greatest, separated by a comma, brackets on the edges, and no repeat of numbers for the domain and range. All right, let's take a look at another example right below here. So the domain, again, if I look at the first numbers, I could even underline them if I wanted. I see 8, 3, 4, 0, 1. No repeats, so that's good. So I'm going to write least to greatest. So here I go, 0, then a 1, then a 3, 4, and then an 8. All right, and then if I go ahead and write the range, least to greatest, so I see a 5, 1, 6, 3, 2, no repeats there. So I start with the 1, 2, 3, 5, 6. I got them all. And again, the domain represents the x values and the range represents all the y values. And I should also add that the domain, the set of all x values, is also the independent variable, or we could also say this is the input values. And the range is all the output values. And we'll talk about that here throughout our unit, but you'll see a lot of different terminology that really represents the same thing. So the independent variable, all the input values, or all the x values all go with the domain. The dependent variable, the output values, or the y values all go with the range. Now let's take a look at functions. There is exactly one output for every input, or exactly one y value for every x value. This means we cannot have repeats for x values, but we can have repeats for y values. And we'll take a look with the following examples below. So let's determine if the following relationships form a function. As I look through the values here, in just the x values, for starters, the 1, 2, 3, 1, 4 are all of the domain or the x values, and so I see a repeat here. I see a 1 and a 1 there, so this would not be a function. Now let's look at the next example. If I look at the x values, 8, 3, 4, 0, 1, I don't have any repeats there. And if you notice, even in the y values, I don't have any repeats either, but that doesn't necessarily matter. So this would be a function. Now let's look at some graphs that are below here on the screen, and let's determine if they are a function. And we are going to use what's called the vertical line test. So here I have a line, and you could use your pencil, any line, and as you go over that shape, if you hit any 2 points at the same time, that means you do not have a function. That means there are really two of the same x values, which we learned earlier in our notes that do not make a function. So let's use our vertical line test, and I'm going to go ahead and go over this graph here, as you can see, and if I hit any 2 points at the same time, which I do, right now I'm hitting 2 points of that graph at the same time, which means this would, and I could continue going through that graph, but I already know I hit 2 points at a time, so this would not be a function. You can also see, for example, you hit two of the same x values at the same time multiple times, right? So that means that that's not a function. Now let's look at this next example. Again, vertical line test. So I'm going to go over this graph, and I'm not hitting any point at the same time with this line, right? If I hold that line vertically, vertical line test. So this would be a function. And again, if I look at the graph, I don't see any of the two same x values ever, or I don't see two of the same x values at all. Now I'll look through this last graph, and as we go through this example, I'm not hitting any two of the same points at the same time, so I would not have the same x values, so this would be a function. And again, we can determine with a graph if we have a function by the vertical line test. Thanks for listening. Have a great day. Bye.